So section 1.12 is not really any different of a section than 111. It just needed to be split across 2 days. So this is day 2 of the same things we were working at before. A solution is a value that makes an equation true. So we're going to be looking for the opportunity to check and make sure that solutions actually work, or that a value is actually a solution. And you can use this on any equation. So we talked sort of in passing. We didn't do it, but we talked in passing about how you could check this with your other problems last time. But we're going to actually show it for a particular example on this one. So example number 1 and 2 both have the equation 17 equals 6x minus 1. And what we're wanting to do is we're wanting to see if they're actually solutions. So to check and see if it's actually a solution simply means to use that number in the equation in place of the variable and see if it works. So if it works, then it will be that 17 will equal 6 times 8 minus 1. And so we check. What's 6 times 8? 48, and 48 minus 1 is 47, which most certainly does not equal 17. So this is not a solution. I'll write it out. And we'll do the same thing for the number 3. 17 equals 6 times 3 minus 1. 6 times 3 is? And 18 minus 1 is 17. So this one works. So this one is a solution. When we're dealing with equations, if an equation has a solution at all, it will have at most one solution, equation that's linear. I should say it that way. Sorry, a linear equation. But some equations actually have the ability to have more than one solution. So you can't actually just say, oh, I found one that works, therefore everything else doesn't work. Not always true. So be very careful about assuming that. We're going to also look then at solving equations. So we solved equations last time. What we're doing in this set of equations is that we're simply looking at equations that are a little bit more challenging. Okay? So we're just taking it up a notch on how difficult they are to solve. So if you're taking a look at number 3 actually looks a fair bit like some of the ones that we did last time. Number 4 makes things more complicated. What is going on with number 3? What would I do as my first step? Yeah, multiply both sides by my 7. So we're going to multiply by 7 on both sides. That will cancel the 7 in the denominator on the left, leaving me with x plus 23. On the right, 3 times 7 is 21. And then what would I do to solve for x? Subtract 23. So on the left, these two add to 0, leaving me with x. And on the right, what do I get? -2 is correct. So I'll only do it on the first couple, but you can check every single solution doing exactly what we did on problems 1 and 2. You can take the solution that you got down here, in this case -2, and you can plug it back in for x to see if it works. So if it works, -2 plus 23 over 7 should equal 21. Is that one? Sorry, it should equal 3. One step before. So on the top, I would do my numerator first. -2 plus 23 is, actually it's positive 21. 21. And 21 divided by 7 is 3. So not only does it check out, but it actually means that we did the original problem correctly because we got the right solution. Make sense? Number 4 has a bit more going on. When you look at number 4, what would you like to do first?
Subtract the 9.
Okay, we could do that. We can subtract the 9. So I will have -31 minus 9, which is, -40 on the left. And on the right, I still have the 3y and the -8y, because these two added to 0. Now what? Yeah, you got to put the y's together. And we could have done that as our first step, too. Either way, it would have worked just fine. So what is 3y minus 8y? -5y. Good. Equals -40. Then what? Yep, divide by negative 5. The negative 5 and the y are multiplied, so we'll divide to eliminate it. This cancels on the right, leaving me with y. On the left, negative 40 divided by negative 5 is 8. So this is my solution, and this is the last time I'll do it, but we're going to check it just so you can see that we can do that. We always check it back in the original equation before we did any processes in case we made a mistake in any of our processes. So I have negative 31 equals 3 times 8 plus 9 minus 8 times 8. So this is what we're checking it in. So I don't do anything on the left. It's already a single number. 3 times 8 is 24. I have 24 plus 9. 8 times 8 is 64. You're welcome to grab a calculator if you wish. You want to check to see is 24 plus 9 minus 64 equal to negative 31. I see some heads bobbing. It does. It works. So we did, in fact, find the correct solution. So I won't check it on every single problem, but especially when you get to the test and you end up finding yourself at the point where you've got 15 minutes left or something like that, you could go back and do every single problem and check it. And you could do it with your calculator even, right, to make sure that you didn't make any mistakes along the way. So it's a useful thing to do. All right, number 5. We have a couple of options. What would you like to do first? What, Trinity? You want to subtract the 11. Okay. You can do that. So on the left, that adds to 0, leaving me with 15y. On the right, I have negative 18 plus 13y. Then what? Subtract the 13y. Good next step, rather. I'll continue over here since I'm out of space. 15y minus 13y is 2y, and it equals negative 18. The pieces here added to 0, leaving me with negative 18. Now what? Divide by 2. Okay, negative 18 divided by 2 is negative 9. And while we won't do that, we could check it if we wanted to, right? Yeah. All right, number 6. What would you like to do first? Yeah, this is one where I don't really have choices like I had before where there looked like there's some distribution, but maybe I could divide it. The problem, of course, on this one is that I can't divide it because there's a 3y on the other side too. That's not actually got the multiplication by 7 with it. So we're going to distribute the 7 through. So I have 25 on the left, 7y minus 35, in the middle, and then plus my 3y over there. Now what? A couple different options.
Add 35.
Okay, we can add 35, you bet. What is 25 plus 35?
60.
It is 60. So in the middle here, these add to 0. Now I have 7y plus 3y. Now what? Add my y's to give me 10y. 60 equals 10y. Yeah, so we'll divide by our 10. So the y is equal to 6. Okay, good so far? They're just getting messier as we go. Here's number 7 for you. What are we going to do on number 7?
Distribute.
Yeah, we're going to start with the distribution like we did in the last one. We just have more of it to do. So we're going to distribute the negative 5 and a positive 5 on the other side. Negative 5 times negative 4u is 20u. Negative 5 times positive 5, negative 25. Don't forget the pieces that didn't have the distribution. They're still there, right? Minus 9u. Then I have 5 times u, so 5u. 5 times 7, or 5 times negative 7.
35.
Yep, 35, negative 35. And then I have a minus 6. So what would you like to do next on this?
Combine.
Yeah, I think probably combining the pieces that match on each side. Yeah, so like there's a 20 here and a 9 here. There's a 35 here and a 6 here. So on their respective sides, without shifting anything, we should be able to simplify each individual side. So 20u minus 9u is 11u. And I still have that negative 25. And then I have my 5u. Negative 35 and negative 6 is negative 41. Okay, it's significantly improved. A couple of options. What do you want to do next? Subtract the 5u. Okay. So we'll subtract 5u from both sides. So that's 6u minus 25 on the left. These, of course, add to 0 here. And then I have the negative 41. Now what?
Or add 25.
Add 25. I agree. So 6u on the left, because these added to 0. What is negative 41 and positive 25?
Negative 16.
It is negative 16. And then what? Divide by 6. 16 does not evenly divide by 6, but they do have something in common that can be reduced. What will they both divide by? Yeah, we can divide them both by 2. So I get negative 8 over 3. And this is an example of one where I can't change it into decimal notation because I'll get a repeating decimal. So we'll leave it in fractional notation. Okay, problem number 8 is missing some instructions. It's in my notes, but it's not in your stuff. So just write the instructions into the side and like note that you're supposed to have these instructions in here. This set does not actually want you to solve. There's going to be a couple in your homework, so pay very close attention to directions where they're not asking you to solve. They're simply asking you to rewrite without fractions. Okay? It's sort of an intermediate step to the solving of this type of an equation later, but they didn't ask for you to solve this, just to rewrite it without the fractions. So what we need to do is we need to figure out how to get rid of those fractions. And in particular, it's those denominators that are causing us problems. So what we do is we take a look for a least common denominator, or you can look for a common denominator. And I'll do it both ways so you can see how both work. Common denominator is probably the easiest because all you got to do is multiply the two denominators by each other. 4 times 10, 40. Okay, so let me do it with the common denominator first. So I found 40, and what I do is I multiply each piece by 40. So 40 times 2 minus 40 times 3/4 x equals 40 times 9/10. Dots between, parentheses between, it doesn't matter. I guess I could be consistent anyway. We'll put parentheses. 40 times 2 is 80. The reason I like the 40 is because the 40 and the 4 will reduce, right? What is 40 divided by 4? 10. So now here I have negative 10 times 3x, which is negative 30x. On the right-hand side, again, the reason I like the 40 is because it will reduce with each denominator. 40 divides by 10 perfectly to give me 4. And 9 times 4 is 36. Now, common denominators are simple to find. You just multiply the denominators by each other. But they're a bit of overkill. They actually multiplied by something bigger than I really needed when I multiply by a common denominator. They're still fine. There's nothing wrong with doing that. It's just one of two approaches. The other approach is to find the least common denominator. So we've found least common denominators before. We did that earlier this semester. And what we did is we factored each of the values. So 4 factors into 2 and 2. And the 10 factors into 2 and 5. You guys remember this? And we asked ourselves first, what do they have in common? And they have a 2 in common. So when we do that, my least common denominator gets the matching 2. And then it gets everything that got left out. So 1 more 2 and a 5. What's 2 times 2 times 5? It's actually 20. So why was 40 overkill? Well, because it got an extra 2 from each of the 2 factors, right? It got both of the 2's from the 2 times 2 is 4, and it got both, and the additional 2 from the 2 times 5 is 10. So if I use 20, it's actually sufficient, and it will eliminate my fractional denominators as well. So I have 20 times 2 minus 20 times 3/4 x equals 20 times 9 over 10. So you can see the 20 and the 4 will divide again. What's 20 divided by 4? It's 5. 20 divided by 4 is 5. Are we good?
Yeah, I was looking at the 22.
Above, yeah. The 20 times 2, well, yeah, I didn't do it yet. 20 times 2 at the very beginning, I should have started in order, but 20 times 2 is going to be 40. I reduced in the middle the 20 and the 4 to give me a 5. Now I have negative 5 times 3x, which gives me
15x?
negative 15x. On the right, again, the 20 and the 10 divide perfectly. 20 divided by 10 is 2. 2, not subtraction, division. So 20 divided by 10 is 2. And 2 times 9 would be 18, which I almost said. So either of these are actually perfectly viable answers to the question. And there's others that you could use, but there's no reason to make them any bigger than you need. So a common denominator would multiply all the denominators together. And then a least common denominator actually ends up finding the smallest one that works. So why? Why do we want to do that? Well, to be honest, we want to do that because it's easier to work with integers, right, positive and negative whole numbers inside of a problem to solve than it is to work with fractions. So when you end up with something like number 9 and there's all these fractions involved, you're not like, ooh, I don't want to add and subtract fractions. You just eliminate them instead. So I'll do a couple of these where I'm finding either the common denominator or least common denominator. Let me actually find the common denominator on 9 just so you can see it work. And then I'll find a least common denominator over here on the number 10, which happens to be the same as the common denominator on that one. But so to find a common denominator just means multiply the 2 denominators together, 6 times 8. 6 times 8 is 48. So if I use a common denominator on number 9, I will multiply each of my values by 48. So 48 times u over 8, 48 times u over 6, and 48 times 7 over 8. Okay, so again, why do we choose 48? It's because they're going to evenly divide by the denominators. This is 48 divided by 8. What is 48 divided by 8? 6. 6 times u is 6u. I have a subtraction sign next. I have 48 divided by 6.
8.
That's 8. 8 times u is negative 8u. And then I have my 48 times 7 eighths, so 48 divided by 8, which is 6, and 6 times 7 is 42. Now, if we had the earlier directions, the ones I had over here that just said eliminate the fractional denominators, right, we would be done. These directions actually want us to solve, okay? So we're taking it one step further here. What is 6u minus 8u?
2u or negative 2?
Negative 2u, good, equals 42. Then what?
Divide by negative 2.
Thank you, divide by negative 2. What is 42 divided by negative 2? Negative 21. Okay. The next one is actually least common denominator or common denominator, and the reason is because 3 and 5 are prime, right? So if you try to break 3 down, it doesn't break down. You try to break 5 down, it doesn't break down. So it actually still ends up being the same as the common denominator here. That doesn't happen on the other problem if I'd done it that way, and I would get 15. So we're going to use 15 to multiply all of our fractions. So we're going to take 15 times negative 5 over 3x. And then I have minus the 15 times the 4 over 5 equals my 15 times 4 over 5x. And then I have my 15 times my 3. So again, each of those denominators is going to divide the 15. So the first one is 15 divided by 3, which gives me 5. So now I have 5 times negative 5x. Negative 25x. The next one I have a 15 divided by 5. That's the 3. I have negative 3 times 4, negative 12. And then I have a 15 times 4/5, so 15 divided by 5. That gives me another 3. 3 times 4x is 12x. And the last one, there's no denominator. I just need 12 or 15 times 3, which is, do you know? 45. Yep, it is 45. So you might not like the process taken to get there, but what we get at this point without the fractions is definitely worth the effort. This is so much easier to solve than if we just dealt with the fractions all the way. It really just is. So if I'm looking at this one, I have a couple of options. What would you like to do first? Add the 12. Okay. So if I do that, I have negative 25x on the left. These add to 0. I have 12x on the right. And let's see, I have 57. Now what? Yeah, so we'll subtract the 12x to group the x's together. So on the right, I have 57. On the left, I have negative 25 and negative 12. What does that give me? Negative 37x. Now what? Divide by negative 37. 57 and 37 are both prime, so there's no simplifying. So this is simply the atrocious looking answer, negative 57 over 37. It's awful looking. But it would have been much more awful. Much awfuler. That's what it should. It should be much awfuler if we had done it with the fractions all the way through. It would have been ugly. Super ugly. All right, so this is our last one where we're looking for a common denominator, least common denominator. So if we did a common denominator on this one, it would be 4 times 2, which is 8. What's my least common denominator here? It is just 4. And the reason I can say that is because 4 breaks down into 2 times 2. 2 is already prime, so they have a 2 in common, so you get one of the 2's. And then you have the leftover 2, so it is 4. Okay, so that's the process that it goes about. But 4 is your value. You can either multiply by 8 or 4. Take your pick. I'm going to multiply by 4 because my numbers will stay smaller. So I have 4 times negative 3. I have 4 times negative 3x plus 3 over 4. Minus the 4 times 2x plus 3 over 2. And I tried to do it that way. I think I'm just going to put the negative in front of the 4. I can have a choice. It doesn't make any difference. I'll just keep the negative outside with the 4. May look a little bit cleaner that way. All right. 4 times negative 3. Negative 12. All right, in the middle, this 4 and this 4 cancel completely. I do still have the negative on the outside, so I need to distribute that negative into the 3x and the 3. So I have negative 3x and negative 3. The other one, I have a 4 divided by 2, which gives me 2 on that one. So I'll be distributing a negative 2 through to the 2x and the 3. So negative 2 times 2x is negative?
4.
Yep, negative 4x. And then negative 2 times 3 is?
Negative 6.
Negative 6. So we have a lot of pieces on the right-hand side, and some of them combine. So tell me something that you see that combines on the right-hand side.
6.
The negative 6 and
The negative 3.
the negative 3. So that's negative 9. I also have the negative 3x and the negative 4x, which will give me what?
Negative 7.
Negative 7x. So those are all my pieces on the right that combine. I still have a negative 12 on the left. Now what? Add the 9. What is negative 12 plus 9? Negative 3. So negative 3 equals negative 7x. Then what? Divide by the negative 7, right? Because it's grouped with the x. So these, of course, will eliminate. I can't do a whole lot with that, right? 3 and 7 are prime, but they are both negative in this problem, so I can't eliminate that. So this is actually 3 over 7. A negative divided by negative is a positive. So there is something that I would like for you to be aware of. You'll encounter them looking a little bit differently on your notes, or not your notes, your homework. It is possible for a problem to have 0, 1, or infinitely many solutions. Every problem that we have done so far has had one solution. At the end, we got x equals something, u equals something, k equals something, whatever. They were all one solution. So I want to show you how things look when they either have infinitely many solutions or no solutions, because we haven't seen any of those yet. Okay? So on the first one, what would you do to solve this first problem? Distribute. So you start the same way, no matter how the directions are stated like this. You're still just going to solve them the same way. We're going to distribute this through. So this is 4x plus 8 equals 4x plus 6. Then what would you do? Subtract 8. Okay, so we'll subtract 8. There's a couple of different options. That's one option. So now I have 4x equals 4x, and then 6 minus 8 would be negative 2. Now what?
Subtract 4x on both sides.
Subtract 4x on both sides, and what is going to happen?
Answer.
Yep, there's no more x's left. And now your equation says 0 equals negative 2, and that is
No solution.
not true, right? It's false. So you're exactly right, Harrison. It's no solution. So anytime in this process, and we could have done it here too, right? We could have, instead of subtracting the 8's, we could have subtracted the 4x's. And if we'd done that, we would have ended up with an equation that says 6 equals 8. So if at any point in solving you get just numbers left over and they're not true, then the answer is no solution. And if you want a symbol for that, some of you have done this before, you got a 0 with a line through it. So do not use 0 with a line through it to mean 0. It means no solution. Okay? Let's do the other one so you can see how the opposite happens. On the left-hand side, we can combine some pieces. Agreed? Those two would make me an 8x plus 6. And on the right-hand side, we can distribute. And I'll get what? 8x plus 6. So if at any point you get an equation where the two sides are identical, this one is, right? 8x equals 6 plus 6, 8x plus 6 equals 8x plus 6. If you tried solving, eventually you would get down at the end to 0 equals 0 if you shifted things around. So instead of getting 0 equals 2 or negative 2 like we did before, we get 0 equals 0 if we attempt to keep trying to solve this thing. When that happens, there are infinitely many solutions. And as you were aware, none of that happened in the previous 11 problems. Every problem before that, you ended up with a single solution at the end. Okay? So it actually looks a little bit interesting. If you have your homework with you, grab it out for me for just a second. And look at the very last problems. What they do is they give you these sort of boxes of things. Does everybody see those? I'm gonna borrow yours. Does everybody see them that look like this? Those are the problems that they're wanting you to find out. Do they have infinitely many solutions? Do they have no solution? Do they have a specific solution? And if they do, it'll come out in the wash, right? Eventually it'll work out and you'll get u equals 7 or something, and then you've got the one solution. So you solve them the same way, it's just that what happens toward the end is a little bit different. Any questions? Yep, Jenna?
Is the x equals, does that mean the infinite anybody, or is that mean like there is one solution?
Yeah, so on number 12, when it says infinitely many, it actually means that any x value will work
I mean,
in
like
this
29.
context. On what?
I mean like 29 with the homework.
Oh, I didn't look at the homework specifically. But if you have a problem that ends up like 12, where you get the same thing on both sides, it means that it's all real numbers. X is anything. If you get a problem that ends up being like number 11, where you have something that's absolutely not true, it just means no solution. Yep.
Do we have any fraction or decimal answers?
You could definitely have fraction or decimal answers. Keep in mind that I'm fine with decimals as long as they terminate, which means they stop. So if you get something where it's got like a repeating nature to them, we're going to leave it in fractional form. You can always leave it in fractional form, but you're welcome to put things in decimals if they're like, 0.25. That's fine. Then you can do that if you'd like. Any questions? All right, so we're going to call it quits for today. You've got one homework assignment, number 12, that you will bring back with you next time. We'll do homework questions at the beginning first, and provided the grader gets this homework back to me, we'll do the questions that you might have from the homework that's being graded, and then we'll take our quiz, and then we'll do a review. Okay, so there is a review inside of Canvas. You need to have it either printed out, or some of you I know are working on tablets in class, that's fine. But we're going to be doing that review in class. And that review is super, super valuably important. All right?
We're doing that on Thursday.
We're going to do that on Thursday. So make sure that your review is with you in class Thursday to work on. Okay?
School, if it's on a tablet.
If you're doing a tablet, like I know I've seen Jenna doing hers that way. I've got some other students in my other classes. Okay, well, I saw you. Yeah, so if you have it on a tablet and you can write on your tablet to do it, I'm okay with that. As long as we're doing tablet, not YouTube. Y'all know.